Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about what are the various definitions and terminology on basic mathematics and probability for data science. So before going to see that, what is the first question is what is a matrix? So matrix is nothing but a set of elements organized into rows and columns. So this is the rows and this should be the column. So the matrix are like plain numbers in many ways, so that can be added, subtracted, and in some cases it should be multiplied and inverted. So some other examples is that, so here I have one matrix and B is the under matrix. If I want to know what should be the dimensions of the matrix, so it should be of 2 by 2 and this should be the matrix of 1 by 3. So whenever the matrix multiplications are not possible, means whenever the column of first matrix should be matched with the row of the second matrix, and it should be usually denoted with the cross symbol. And so the matrix with one column and one row, what we're able to call it as a vector. And if a matrix has equal number of rows and columns, then it should be called as a square matrix. And usually the matrix are going to be represented in uppercase and lowercase letters are denoted for vectors. Matrix multiplication. So multiplication of matrices require the conformability conditions. So what is this conformability condition for matrix multiplication is that, so the column dimensions of the lead matrix and must be equal to the row dimension of the lag matrix. Okay, so if the column matrix of the first one and the row matrix of the second one is going to match, then only matrix multiplication is going to be possible. So here we are going to have some of the examples like A into B. So A is going to have a set of two matrix values and B is the other set of matrix. So if I'm going to multiply A into B, so what should be the value? So A1, B1, 1 and A12 and B12. So this one I have to multiply, and again this one is going to multiply. So the first one, so this one is going to multiply with this, and the second one is, so this one is going to multiply with the second one, and next one is, so this one is going to multiply with the third column. So here, so 1 by 2 matrix and this should be 2 by 3 matrix. So the column of the first matrix matches with the row of the second matrix, so multiplication is possible. And finally what I'm going to get is 1 by 3 matrix. And next one, what is the transpose matrix? So if the matrix, the transpose of the matrix is under matrix, so should be usually written as A transpose. That means where the rows are going to be converted into columns and columns is going to be converted into rows. And formally this one should be, we're going to have some of the rules. Normally what I'm able to call is, if I'm going to apply the transpose of again A, then I'm going to get the original matrix. So if A is the matrix, A transpose is the matrix. Suppose if I'm going to have 1, 2, 3, 4, and A transpose should be 1, 2, 3, 4. And if I'm going to again apply the transpose of this, again I'm going to get the same value. That should be equal to A. So like this we can able to sum out the laws also. And next one is that mention different types of matrices. So normally we are going to have different types of matrices like identity matrix, null matrix, diagonal matrix, and then system symmetric matrix and all. So what is this identity matrix? So identity matrix is a square matrix with 1 along with zeros everywhere, and null matrix is the one which all the elements are to be 0 only. And both the diagonal matrices are often called as often diagonal matrix, that should be 0. And So if I'm going to consider an identity matrix like this, so what I'm going to say that is, so all the diagonal elements should be 1. So null matrix means all the elements should be 0. So that is the only indication we're going to represent it. So next one is, what are the different types of matrix operations? So matrix operations will be, suppose if I'm going to add the two matrices, 1 2 3 4, 1 2 3 4. So I can able to perform addition. So simply I can able to add the corresponding elements 2 4 6 8. So a plus c and b plus f, c plus g and d plus h. Similarly, if I'm going to subtract, you can able to subtract the elements from corresponding elements of the matrix, and then we can able to multiply. So I can able to perform multiply. The row of the first matrix should be multiplied, and the column of the first matrix should be multiplied. And similarly for this one, I can able to get, so the row of first matrix should be multiplied with the column of the second matrix. And similarly, if I'm going to consider this one, so I have to multiply the first this. So the row of the first matrix should multiply with the column of the second matrix, and again I have to multiply this. So how can I able to obtain this scalar matrix? So Ka into Kb, Kc into Kd. And some of the basic matrix operations what we are going to have is that, so matrix addition, so that should be multiplied. How can I able to multiply? So examples I have explained. So addition, subtraction, multiplication, and then scalar value. So discuss the different types of laws of matrices. So laws of matrix addition and multiplication. Suppose if I'm going to have a matrix from A plus B is equal, similarly that value should be equal to B plus A. Okay. So A plus B. So A is the one matrix. B is another matrix. So if I'm going to perform addition, this is the value I'm going to get it. Similarly, if I'm going to add B plus A, so this is the value I'm going to get it. So the almost all these values should be same. There should not be any change in the value. And according to this matrix multiplication, so if I'm going to write A into B plus C, so that should be equal to AB plus AC. So let's see example how this one is possible. So for in case of matrix multiplication, so if I'm going to multiply two matrices, then that should not be equal to the B into A. In case of A plus B, if I'm going to write, then it should be B plus A. Now see the values. Suppose if I'm going to multiply the two matrices, so the values of what I'm getting is AB values this one, and similarly if I'm going to multiply B into A, then these values are going to get this one. So they should not be equal to this both the matrices. So that's why AB is not equal to BA. Whereas in case of A plus B, it should be equal to B plus A. And some other exemptions that should be on commutative law should be AB is equal to BA. So where B should be the scalar, identity, and then inverse. So here what I'm going to say that AB is equal to AC when I'm then only automatically B equal to C. This is the proof what I'm able to set that. So inverse of the matrix, so identity matrix. So if I'm going to multiply AI, so then automatically it should be A. Suppose if I'm going to have a matrix like 1 1 1 1, so if I'm going to multiply with 0 1 0 0 1, so then automatically 1 0 0. So if I'm going to take a matrix like A equal to 1 0 0 1, then identity matrix, if I'm going to take 1 0 0 1, if I'm going to multiply it, so the values what I'm going to get is 1 0 0 1 only. So in case of this one, A into M, B should be under matrix, which should be right inverse of A, then if and only if AB is equal to IM. And similarly, if A is on matrix, and C is left inverse if and only if C is equal to IA. So discuss briefly about the vectors. So vector is nothing but an defined object with magnitude and direction. And so here the vector is a one-dimensional array, so representing the series of numbers, where array should be a list of numbers as well. So normally this one should be represented as a symbol with an arrow or bold font. So if I'm going to write with a bold font, or I can able to represent with an arrow. This should be the indication of the vector. So normally these vectors are going to be broken into components, which are individual members of the vector. So can you use some of the notations like this? So x, the vector x should be written it as like this. So here x of 1 should be 1, and x of 2 is equal to 2, and x of 3 is equal to 3. If I'm going to have 4, 5, and then 6, this should be 4, 5, and then 6. So here what I'm going to say that is, so the vectors should be of different types. So normally they should be one dimensional vector and generally denoted as symbols, a symbol with an arrow mark. So let's see the other example. So how can I able to write in R programming, in Python programming. So import numpy. So numpy is the package what we need. So x is equal to numpy dot array of 368. Suppose if I'm going to have a problem like this, so consider what we can able to measure the average satisfaction rate for the employees of three departments, and so 57 for HR and 89 for engineering, 90 for management. So the same thing what can I able to represent in the form of a vector, the values of x1, x2, and x3. And what are the arithmetic symbols we're going to see in this one? So here we're going to have summation. So summation is the one of the symbol we're going to use, where we can able to calculate the mean value of all the values, not generating a sequence of numbers as well. The next one is proportional. So proportional is the arithmetic symbol. So where you can able to use, so the lower alpha symbols represents the value that is proportional to each other, and this means one value changes the does other also. So and the values can be either directly or indirectly related. So if the values are vary directly, they can be able to move in same direction. So similarly, if they vary indirectly, then you can able to move in opposite direction. And dot product, so this is the another operator where you can able to perform like addition, subtraction, multiplication in between the two vectors. Suppose if I'm going to have two vectors like 3, 7, and 9, 5, so I can able to multiply. So 3 into 9 and 9 into 5. So similarly, if I'm going to have another vector, so this one I'm going to multiply with 3, 4, and 5. So I can able to write 5 into 3 plus 1 into 4 plus 3 into 4. So like this we can able to perform the dot product, addition, multiplication as well. See another example. So if I'm going to have two vectors, so this one is going to be multiplied as well. And graphs is an arithmetic symbol where you can able to represent a Cartesian graph along the axis x and y. So this x and y should be the very standard one, where horizontal line is going to denote it as x and vertical line is going to denote it as y. And so where you can able to represent the coordinates on this xy plane. So how we are going to represent is x1 y1 is one point and x2 y2 is another point. So how can able to find the slope between the 2 points? That should be given by the equation. So slope is equal m is equal to y2 minus y1 by x2 minus x1. And logarithmic and arithmetic exponents are the other kind of symbols we are going to use. So if I'm going to write 2 power 4, so that much times the base value is going to be repeated, and the logarithmic is a function, is a number, so where you can able to denote it as log and then some value and base 2. So 16,244 is going to be write it as right. So the logarithmic value should be 4. And discuss briefly about the set theory. So here, so set theory is going to be used in many mathematical operations at the set level. So it is sometimes a thought of basic fundamental group of theorems. And for our purpose, we are going to use the set theory in order to manipulate the group of the elements. And set is nothing but a collection of distinct objects. So how can I able to write in Python is that, so S is equal to set of values. I have to mention it. So these are the set values. So simply if I'm going to write, so what is the elements of the set? So set S is equal to 1, 2, 3. So these are the elements repeatedly occurring. So this repeated elements is going to be eliminated and unique elements is going to be written here. Suppose if I'm going to have the set 10, 20, 30, 10, 20, 30. So this set can be simply written as the set of values 10, 20, 30. No need of repeating that. So and so here the magnitude of the set can be represented as like this. So it's can able to write it as magnitude of the set. So that means the number of elements that are present in the set can be represented as this. And suppose if I'm going to know this, so what should be the length of the set? I'm going to have a function like len of s, where I'm able to return the function the number of elements present in the set. Similarly, if I want to represent whether the particular element is belong to the set S or set A or not, if I want to show it, then I have to make use of this epsilon symbol. That should be epsilon notation have to be used. And so see the example, we are going to have two sets. So set A is equal to 156 and set B is 1567. So by seeing this, all the elements of this set is present in the element in set B. So that means what can able to say that is A is subset of B. That means the elements which are present in set A is also present in set B. So then only you can able to write. So we should not write B should not be subset of E. So this is wrong. So why? Because the B is going to have more and A is going to be less, but the elements should not be, some elements is not there in set A. That's why I'm going to write A should be subset of B here. So what is a set is the definition. So set is nothing but a well-defined collection of distinct objects, and all the objects in the set what can able to call it as elements or members of the set, and usually this should be represented by using capital letters of ABC and lowercase letters denotes the element of the set. So this should be the definitions of the set here. And let's see the example how we are going to represent a set. So the collection of vowels in the word you can able to write. So set of O is equal to vowels. So what are the vowels that are present here? E, E is not there. E, I is there. O is there. So these are the elements of the set vowel. And another example is a collection of real numbers that satisfy the equation. So the real numbers which is going to satisfy this equation is, so 1 is not possible, 2 is not possible, and 3, if I am going to apply 3 square 9 minus 9, that is would be 0. So the elements of the set only that satisfy the condition is 3 here. Similarly, if I am going to use the 2 to is it positive integer, that should be divisible by 5. So d is equal to, that should be divisible by 5. So that is 10, 15, 20, 25, 30. So these are all the elements of the set. And the collection of footballs in the national football game and collection of intelligent numbers in the United States Congress. So these are the examples of the set. An empty set, so that should be a set with no elements should be considered as empty set and also called as a null set. So it should be denoted by symbol alpha. And set of real number sets that satisfies the equation is that. So there should not be any kind of set that is possible for satisfying this equation. So this should be the empty set. And next one is finite and infinite set. So finite set is the one which can be counted. So example, a set of two-digit positive integers. An infinite set is the one which cannot be counted. So set of integer multiples of 5. So these are the two types of sets. So finite set and then infinite set. So what is the next one is cardinality of the set. So cardinality is going to be represented by n of a, so that it can able to represent the number of elements that are present in the set. So for finite sets A, so n of A is the number of elements of set A. So if I'm going to write n of A is equal to infinity, so infinite set. So all the elements in the set should be infinite. So what we're able to call it as infinite set. Specifying a set. So for this, list the elements explicitly. What can able to call that should be a well set. And if I'm going to display the elements implicitly, so this should be that. And we can also be use a set builder notation for specifying the set. And how can able to denote that is, so set uq is equal to x such that x belongs to p by q, where p should be and p and q are the integers, where q should not be equal to 0. So how can the set is going to specify? So either explicitly I can able to represent the set, or I can able to represent the set implicitly. So under convention, what I'm going to use this is set builder notation. So the convention for this notation is that, so we have an element, so x such that, so x belongs to p by q, where p and q are the integers. And next one, what is the universal set? So universal set is nothing but a set U that include all the elements under consideration is considered as universal set, and depends on the context you can able to know. And example, so set of Latin numbers, set of natural numbers, and set of points on the line. So that should be represented as a universal set here. So the universal set is the unique set. Uh, that includes all the elements under the consideration in particular discussion. So depending on the context, we can able to define the set, and the set of all the Latin numbers, set of natural numbers, set of points on the line should all treated as the universal set. And membership relation. So here let A be the set and X be the object. So how can I able to represent the relationship between the two elements? So one can able to belongs. So X belongs to A. That means a set A consists of X, Y, Z something. So where X should be the element of the set A. So how can I able to write? So X belongs to A, or X is a member of A, or X is the element of A. Like this, we can able to make convention. Can able to show it. And so if I'm negation, that means suppose the element does not belongs to X, then I have to represent like this. So belongs, and this should be does not belongs to element. So here we're going to have an oval set. So where E is the element of the set, so that's why I'm going to write it as E belongs to E. And next one, what is the equality of sets? So here we are going to have two sets like A and B. It should be denoted A equal to B. And if the elements are not equal, the sets of if all the elements of two sets are not equal, then I can able to write A is not equal to B. So the set of positive integers is not equal to set of prime numbers, or set of odd numbers between 4 and 8 with the set of numbers between 4 and 8, prime numbers between 4 and 8. So odd numbers 5, 7 in between 4 and 8, and prime numbers 3, 5, 7. So these both sets are not equal. Equal only, right? Set of odd integers between 4 and 8. So 3 will not come. Okay. So both are equal, so I can able to say that. So O equal to B. And next one is that what is a subset? So A is said to be subset of B, where every element of A should be element of B. The convention is A subset of B. For each set, A should be automatically subset of A, and for each set B, the pi should be belongs to B. And A is the superset of B if and only if it is going to satisfy the condition that should be A subset of B. Okay. Suppose if I'm going to have elements. So all the elements of it also belongs in B. So 1, 2, 3. So that's why I can able to call that A should be subset of B. For every element that should be subset of A, and the pi should be subset of B, and A should be proper set of B if and only if it is going to satisfy this condition. And next one, what are the set operations are going to perform? So first one is that union. So union of two sets A and B is going to present it as A union B. That means every element of A and also every element of B. So the elements which are common in both the sets should be treated as union operation. Suppose if I'm going to have the set like 1, 2, 3 and B is equal to 4, 5, 6. If I'm going to write A union B, so the set of elements will be the elements of set A as well as the elements of set B. So this and all will be treated as union operation or exclusive, inclusive OR. And next one is intersection. So intersection means this should be written as X such that X belongs to A and X belongs to B. So that means the element should be common in A as well as in common in B. So then I can able to say that this should be the matrix intersection. So let's take an example like if A is equal to 1, 2, 3 and B is equal to 4, 5, 6. If I'm going to write A intersection B, then it should be pi. So no elements is going to be common in both the sets. And similarly, if I'm going to write 1, 2, 3 here also, so A intersection B should be the elements which are common in both the sets. So that should be 1, 2, 3. And next one is complement. So if A is the subset of universal set, and then the complement of A should be the set. So how can I able to write? So A complement is equal to X belongs to universal set and X does not belongs to A. So if I'm going to draw a diagram like this, so universal set and they should be the elements of the set. So A complements means that so the elements which are present in A only but not present in universal set. So some other laws what we are going to have A intersection A complement is equal to pi or A union A complement is equal to pi mu. So what are the various types of Venn diagrams in the set? So this should be the presentation of Venn diagram. So where U should be the universal set and A should be the set of elements that is going to be presented inside it. And some other possible Venn diagrams for two sets should be this. So this should be this is A intersection B and this is the A and B and this one should be treated as B is the subset of A. So that means the elements in B should be 1, 2, 3 and A should be 4, 5, 6 also. So but A should be 1, 2, 3, 4, 5, 6 and B is equal to 1, 2, 3. So these are the elements which are common both. So I can able to represent a 1, 2, 3 and it should be presented as 4, 5, 6. So what should be this complement of set E? So that means all the elements in the universe should be treated as a complement except that the elements which are present in. So diagrammatically how can I able to represent it? Like union of two sets. So this is the set A elements and this should be set B elements. So all the elements in both you can able to represent the union. An intersection means the elements which are common in both the elements that should be treated as intersection. Suppose I'm going to have the elements like 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 7, 9, 15. So 7, 9, 15. If I'm going to take, so the elements which are common in set A, that is 6, 7, 8, and they show the elements which are common set B is also 6, 7, 8. So there should be representation of intersection of two sets. And what are the various sets that is going to be followed by two sets? So if I'm going to have the region R1, R2, and R3, so R1 is nothing but A intersection B complement, and R2 should nothing but A intersection B, and R3 is nothing but A complement intersection B, and R4 should be A intersection component B complement. So this is R4. So this is the region of A intersection A complement intersection B complement, and R3 is nothing but A complement intersection B, and R2 is nothing but A intersection B, and R1 is nothing but A intersection B complement. So what are the various counting tools we are going to have in representation of the set? So if A and B are the infinite sets, so n of A union B is equal to n of A plus n of B minus n of A intersection B. Similarly, n of A intersection B complement should be written as n of A minus n of A intersection B. So these are the two basic computing rules what we are going to be follow here. So n of A union B. N of A union B is equal to n of A plus n of B minus n of A intersection B. So similarly, how can I able to obtain n of A intersection B? N of A intersection B is equal to n of A plus n of B minus n of A union B. How can I obtain n of A? So n of A is equal to A union B plus n of A intersection B minus n of B. So this from this equation itself I can able to extract all the equations as well. So discuss briefly about the vectors and matrices with an example. So vector is nothing but these are the collective objects that is going to be referred collectively, and some position of this floor can also be represented by two numbers. So I can able to write, so 1 foot measure I can able to represent it. So example, suppose I'm going to eat 2 eggs. So what should be the slices of bacon and 2 slices of toast for breakfast? So for this how can I able to represent? So 2 is the eggs and 2 slices of toast and 3 slices of bacon. So this should be the representation of the vector. So similarly I'm going to have a x cost is this and bacon cost and then bread cost is like this. So for representing this vector, so I can able to show it. So we have to divide by dozen. So 1.3 is going to be divided by dozen, and bacon is going to be divided by 12, 16 sorry, and 1.99 should be divided with per leaf. And matrices is another kind of representation that should be collection of finite set of objects. And how can I represent it? Suppose if I'm going to have an example like this, like pancakes, grapes, bilge, or the three types of flat breakfast, uh, but they're going to have different ingredients. So normal definition is that so M by N matrix is a rectangular array of M numbers that is going to be arranged in n dimensional rows and columns, and the row should be this one, and column should be this one. So elements which are arranged side by side and the column is column wise. And dimension is nothing but should be the combination of rows and columns and should be denoted with cross symbol. And incidence of matrix is also present. And vector is nothing but a simple vector which should be of the type n by 1 or 1 by 2 n matrix. So the algebra means, so suppose I am going to have matrix like my wife does not like x, so the breakfast can be of the take the form 0 2 2. So how can we express my wife here? So I can able to do it like this. And adding a vectors, so sum of two vectors is the vector where the I component is equal to the sum of the ith component of the first vector and ith component of the second vector. We can able to present as b plus b dash. An example of the vector, suppose I am going to eat the free cost like this. So what is the vector representation on my concession over the week? So for this I can able to present it. And linear algebra of matrices, they should be added and scaled up in many ways. So if I'm going to have the two matrices, we can simply add the elements and we can also add the scalar value of that element also. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.